Hello. Hi everyone. Good afternoon. Good evening. All right. So we are going to start a new batch for Pratham. This is for grade 9. So welcome you all. So there is a first chapter, motion. So let's begin. So some of you might be seeing me for the first time. Some of you might have already seen me earlier. So if you are meeting for the first time, this is about me. My name is Dr. Akash. I have done PhD in physics from National University of Singapore. I have BSMS dual degree from IISER Pune as ranker in IIT JEE Advanced in 2009 and KPY in 2010. So this is about me. Alright, so if you are watching this live, say hi or do shout out so that I'll know who is watching this video right now. Hi Chaitanya, Hamid, hi, good afternoon, sorry, good evening, Meshram, Chaitanya, hello, great. So these are the topics I'll be covering. We'll start with the motion, then force and laws of motion. Okay, I'll shout out Hamid, Joey, Harish, good evening everyone. Then we'll learn gravitation. This chapter is very important for your grade 9th. Lot of these competency based questions will come. For last 3 years they are coming from this chapter, gravitation. Then we have work energy and last one is sound. Sound is very similar what you have learned in grade 8th. There is little bit advanced than that, but still okay, right? So these are the chapters. So let's begin with the first chapter, motion. So what is motion? First question. What is motion? Whenever you are moving around. Hi Aisman. Alright. Jagannath, Jai Jagannath. Alright. So what is motion? Whenever you are moving. Let's suppose I am moving from sideways. I am walking, I am running, I am jumping. So whenever we do all such activities, we move from one place to another. So what is motion? Whenever the object makes a movement from one place to another with respect to time. So time is always changing, right? Time doesn't stop. All the other things in the world, they can stop. But time is the only parameter which doesn't stop. And because of that, time is always running forward. So whatever we do, we check with time, is it changing? So if the position of the object is changing with time, then we say that object have a motion. Okay. So now let's learn about the distance and displacement. So what do you know about distance and displacement? Have you heard these words before? Distance is very common, right? आपने सबने सुना होगा. What is distance? Distance from Pune to Mumbai is 200 kilometers, or from Delhi to, let's say, Chennai, I don't know, like few thousand, maybe a couple of thousand kilometers, right? So distance we all know, but what is displacement? There is a new term for most of you. So what is displacement? Chaitanya, Harish, can you tell me? Hamid, Mesham, Joey, who can tell me what is a displacement? So let's do one activity. So what is this activity? Let's read. Ram starts journey from point O. So there is a point O. So Ram starts his journey from this point O. He reaches to the point A. So now he has started the journey. So he started here. Then there is a straight line, right? So he moves along the straight line and reach to point A. So Ram started the journey at O, reached to point A. Route of an object. Alright, we'll find out. Then return back to point C. So there is a direction. Then after reaching to point A, he returned back to point C. This is a return journey. Then what is the total distance travelled by the Ram? Can you tell me what is the total distance travelled in this whole journey? So that is distance from point O to point A. What is the distance from O to A? Distance from O to A, this is in kilometers. So from O to A, it is 60 kilometers. So this is 60 kilometers. Then he came back from point A to point C. So what is this distance from A to C? So this is 60, 60, then 10, 60 minus 10 is 50, minus 10, minus 10, minus 5. So that is 35 kilometers. So this distance is 35 kilometers. So what is the total distance? That would be 60 plus 35 kilometers, which is nothing but 95 kilometers. There is a total distance travelled by Ram. Clear? Now, what is the next question? What is the shortest distance between the initial and final positions? So again, let's look at here. What is the initial position? So this point here is the initial position. What is the final position? This point is the final position. So what is the shortest distance? It is this straight line. This straight line between the initial and final position. This is our shortest distance. And how much is that? From 0 to 25. So this is 25 kilometers. So what is the shortest distance from the initial and final position? It is 25. Are these two same? The total distance travelled and the shortest distance, are these two same? Answer is no, they are not same. The total distance is the total path length of this path. Shortest distance, for the shortest distance we only need the initial and the final positions. We don't care about the which path they have taken. Okay, that is a difference. So now let's learn about displacement. So what is displacement? It is the shortest distance from the initial to the final position. This is the called as displacement. What is displacement? It is the shortest path or shortest distance from the initial to the final position. So you look here, this point A is our starting point. All these objects, so there is a object number 1, object number 2, object number 3. They are following these 3 different paths and they reach to this final position or the final point. Initial point, final point. So now they can take any path. You can choose path 1, you can choose path 2, you can choose path number 3. 3 different paths. But what is the shortest path? It is this path number 2. This is the shortest distance, correct? So that will be our displacement. So now the displacement is a vector quantity. It is a vector. So all these vector quantities, they have magnitude as well as direction. They have both of them. So what is the magnitude? Magnitude is nothing but this path length, shortest distance, that is the magnitude. Magnitude is just length of the shortest path. And what is the direction? Direction is this arrow pointing from start to end. This arrow will give you the direction. So displacement is a vector. It has both magnitude as well as direction. Clear everyone? Any questions? Now let's suppose there is your house, your home, and this is your school. So sometimes if it is exam time, then you rush directly from your home to school. You take the shortest path, right? But let's suppose it is not your exam time and there is your friend's home. There is your friend's home. So what you do is you start from your house, you go to your friend's house, then you go to school, or you go to nearby shop, buy something, then take another route and go to school. So these are the different ways possible, but there is only one way which is called as shortest distance, and that we call it as displacement. Clear? So now, yes, again another example, the path or the route can be different, it can be of different shape. You may have to go a longer path. So this is a distance, total distance traveled. So total distance is always going to be greater than displacement. Displacement is written by this symbol. S is used for displacement and there is an arrow on the top. So what does that mean? It means it is a vector quantity. So there is a displacement, and for distance we choose symbol D. So displacement is always less than or equal to distance. Displacement always less than or equal to distance. So when can these two are equal? They are equal when the object moves along a straight line. When the object moves along a straight line, in that case displacement is equal to distance. If the object moves along a random path, this is not a straight line. If it is not a straight line, then displacement is less than distance. Okay, so now the difference between distance and displacement. What is the distance? It is the actual path length. What is the displacement? It is the shortest path between the 2 points. What is the distance? It is a scalar quantity. Scalar means it has only the magnitude, only the length. We don't say, let's suppose two places, your house is 2 kilometers from your school or 4 kilometers from your school. So that is a distance. When we say only the length, that is 4 kilometers. For example, this pen is, let's say, 10 centimeters, right? So that is the length of the pen. So when you use only the length, only the magnitude, these are scalar quantities. And what is a vector? Vector is, you need to tell the direction as well. For example, do you know map of India? So in India map, let's suppose this is a Mumbai and this is Kolkata. So Kolkata is on the east of Mumbai, and let's suppose there is a shortest distance between them is, let's suppose, 2000 kilometers. So what we say, Kolkata is on the east of Mumbai. From Mumbai, if you go to the east 2000 kilometers, then you will reach to Kolkata. So I am specifying both. This 2000 kilometers is the magnitude, and when I am telling go towards east, start walking or driving towards east, so that is the direction. So when you tell both of these, magnitude as well as direction, they are called as vector quantities, right? So the displacement can be positive, negative or 0. Distance, it cannot be negative, it can only be positive or 0. Why distance cannot be negative? Distance is the distance or the length between two places or 2 points. So it cannot be negative. So let's learn how the displacement can be negative. You understood how the distance can be 0? If I am standing here, for 1 hour I am just standing here, not moving. What is the distance traveled? 0. If the object is stationary, not moving, then the distance can be 0. So let's understand how the displacement can be negative. Alright. Okay, before that, solve this question, then we'll come to the negative part of the displacement. So question is, particle is moving freely for 10 seconds. Yes, rest position, correct, Chetan Verma. So the initial and final positions are same after 10 seconds. Which of the following is 0? That is a question. So particle is moving. It is not at rest. If the particle start here, there is a start. It is moving. So particle is moving randomly, and now it came back to the original position. So there is an end point. So the start and the end point, the initial and the final positions are same after 10 seconds. So what is the time? Time is, let's suppose, 10 seconds. So which of the following is 0? So first, distance. What is distance? Distance is this path length. So particle is moving, so distance is not 0. Okay, displacement. Nice, Chaitanya and Chetan, awesome. Yes, distance is not 0. Time is not 0. What is time? 10 seconds. How about speed? Speed is nothing but distance divided by time. Distance is not 0, time is not 0. So speed is not 0. But what is 0? Displacement. Why the displacement is 0? Because the initial and the final positions are same. That is the reason displacement is 0. Clear? Nice, all of you. Awesome. Now, the next question, numerical ratio of displacement to distance for a moving object. So displacement divided by distance, this ratio for the moving object. So object is not at rest, object is moving. What is this ratio? Always less than 1, always equal to 1, always more than 1, or equal to or less than 1. Solve this. So here we need to consider two different cases. Let's suppose case number 1. Case number 1, the particle is traveling along a straight line. So there is a start and there is an end point. There is on the straight line. Video is trucking. Okay, maybe some internet issues. Refresh the page, check your internet. So in that case, displacement is equal to distance. But let's suppose particle is moving around. So now there is a start and there is an end. So this will be the displacement and there is a distance. So distance is more in this case. So there is a case number 1. In case number 2, what do we see? Displacement is less than d. So if you combine these two, what you will get? You will get displacement is less than or equal to distance. So if you divide both sides by d. So what is this ratio? So S divided by d is less than or equal to 1. So what is the correct option? It is equal or less than 1. That is the right answer. It should be D. Nice, Chaitanya. Awesome. Now, let's solve this question. Ant travels 30 centimeter eastwards. Eastwards means towards east. How the direction look like? There is a north, south, there is a east and west. So ant travels 30 centimeter towards east. Let's suppose there is a start and goes 30 centimeter towards east, reach to this point, then 20 centimeter north, then it goes 20 centimeters in the north, finally 15 centimeter west. So it comes 15 centimeter to the west. So what is the magnitude of ant's displacement relative to its original position? So here this one is the initial point, there is the final position, right? So we need to find out. Clear video? Yeah, sometimes it can happen if there is internet issues. So you can refresh your page, so you'll get a clear internet. So what you do is join these 2 points. This look like a, what kind of shape it is? These 2 lines, they are parallel because the angle between these directions is 90. So this is a 90-degree angle. So these 2 lines are parallel to each other. So this is like a trapezium, right? So in the trapezium, what you can do, you can draw a line parallel to this line. So this will become a, what is this shape? Rectangle. All the angles are 90. If all the angles are 90, the opposite sides should be equal. So if this is 20 centimeter, this must be 20 centimeter. If this 15, this must be 15 centimeter. The total is 30. Total is 30. From that 30, subtract 15. So what you get here is 15 centimeter. So now this triangle here, these 3 points, it look like which kind of triangle? This is a right angle triangle. So in the right angle triangle, you need to find out what is this displacement. So that is nothing but our hypotenuse. So hypotenuse square is equal to one side square, which is 15 square, plus another side square, which is 20 square. So that will come out to be how much? 15 square is 225 plus 20 square is 400, which is 625. So hypotenuse square is 625. So from here, what you can find out? The length of the hypotenuse is 25 centimeter. So what is the displacement? What is the ants displacement? It is this length, which will come out to be 25 centimeter. Clear? Now, yes, let's learn about motion along a straight line. For example, you see these 2 cars, red and there is a grey color. So if they start moving, one is going towards left, another is going towards right. Can you see? This red color is moving towards left and right, this grey one is moving towards right. So when the car or when any object move towards right of the x-axis, we say that the displacement is positive. So here displacement is positive. If it goes towards left, displacement is negative. Okay. So here the displacement is negative, displacement is positive. That is the sign convention for the displacement. This is what we have learned in your Cartesian system. This is your x-axis. If you go towards right, we call that as positive numbers. These are the negative numbers. So that is how we consider there is a positive displacement, negative displacement. So motion in the negative direction, there is a motion in the positive direction. So let's find the displacement of each of these particles. So I'll give you a hint how to solve. Let's draw a lines. These dots are the original positions of these particles, and the arrow will tell you the final position. This here, let's suppose, okay, or else, yeah, this is not correct. This is somewhere here. This one is at 10. Okay, done. This is at 5. All right. So now these are the 4 different particles A, B, C and D. So what we have to find? We have to find out the displacement of each of them. So how will you find out? So these are the 4 particles A, B, C and D. So their final positions, initial position, displacement is final minus initial. So let's find out. So here the object A, final position is 7. Final position is 7. What is the initial position? It is 0. So 7 minus 0 is 7. There is a positive. So effectively A is moving towards positive. There is a plus 7. That is a displacement of A. For B, final position is 7. Initial position is 12. So 7 minus 12 is minus 5. So displacement of B is going towards left. Displacement of B is negative. How about the third one? Yes, biology class is also live. That is for grade 10. Biology class is for grade 10. Nah? Okay, we will see about it, what we can do. You want to attend both 9th and 10th? So see here, final position is 10 and the initial position is 2. Final is 10, initial is 2. So what is the displacement? 10 minus 2, which is 8. Again, effectively C is going towards right. And last one, D, the final position is 5, initial position is 9. So effectively 5 minus 9 is minus 4. So here this is the displacement of particle D, which is minus 4. So this is the way to calculate displacement of different particles. Clear? Now there is a homework for you. You have to solve this. I'll tell you what is the question. Object is dropped from an aeroplane. So there is an aeroplane moving and you drop a packet from this aeroplane. So now statement 1 says path of the object is straight line with respect to the pilot. So what pilot will see? This with respect to pilot. So when the pilot see that object dropping, he will see that it is a straight line. That is statement number 1. And what is statement number 2? The path of the object is straight line with respect to the observer on the ground. So let's suppose there is someone who is standing on the ground. He will look at the aeroplane. Aeroplane is moving and there is a packet dropped from the aeroplane. So with respect to that observer, the path is straight line. And which one of them is correct? Are both of them are correct? That is the question. You have to tell me which of the following is correct. This is your homework. Solve it. I'll do this homework in our next class. So until then, bye bye. Take care. Thank you so much. There is a Telegram channel. You can go to the Telegram channel. You will get all the content. All this PDF will be available in the Telegram channel. Alright everyone, that's it for today. Thank you so much.